MS Ramaiah University of Applied Sciences.
Hi students, let us discuss determination of alkalinity. The aim of the experiment is to determine the alkalinity present in the given water sample. Alkalinity is primarily a way of measuring the acid neutralizing capacity of water. In other words, it is the ability to maintain a relatively constant pH. The alkalinity is caused due to the presence of bicarbonates HCO3 of calcium and magnesium, or by bicarbonates CO3 or hydroxides OH of sodium, potassium, calcium and magnesium. Bicarbonate alkalinity is the alkalinity caused by bicarbonates. Carbonate alkalinity is the alkalinity caused by carbonates. Caustic or hydroxide alkalinity is the alkalinity caused by hydroxides. Some but not all of the compounds that cause alkalinity also cause hardness. Hydroxyl ions present in a sample as a result of dissociation or hydrolysis of solutes are neutralized by titration with a standard acid. Thus, the alkalinity depends on the endpoint pH used. The endpoint pH may be 4.5 to 5.1 for total alkalinity and 8.3 for phenolphthalein alkalinity. Apparatus required: burette with burette stand and porcelain tile, pipette, pipette bulb, conical flask, wash bottle. Chemicals required: standard sulfuric acid, phenolphthalein indicator, methyl orange indicator, distilled water. Data collection and tabulation are as shown in the table. Phenolphthalein alkalinity as CaCO3, that is P equal to V1 into N into 50 into 1000 divided by V. Methyl orange alkalinity as CaCO3, that is T equal to V2 into N into 50 into 1000 by V are calculated. Alkalinity relationship is shown in the table. The results of hydroxide alkalinity, carbonate alkalinity, bicarbonate alkalinity, total alkalinity in milligrams per liter of CaCO3 are presented.
Hello everyone. So today we are going to conduct the alkalinity test on the given water sample. So the aim of the experiment is to determine the alkalinity of the given water sample, and alkalinity is primarily a way of measuring the acid neutralizing capacity of water. In other words, we can say it is the ability to maintain relatively constant pH, and the possibility to maintain constant pH is due to the presence of or due to hydroxyl, carbonate and bicarbonates that is present in the water. The environmental significance of conducting alkalinity test is alkalinity is very important for the fish and aquatic life. Also, the large amount of alkalinity will impart bitter taste in the water. Also, sometimes increase in alkalinity also causes or it corrodes the pipes and other distributory or accessory systems of water distribution systems. The apparatus required for the alkalinity test are wash bottle which is used to rinse all the apparatus, pipette, that is 10 ml pipette to withdraw 10 ml sample of water, funnel which is required to transfer the sulfuric acid into the burette, conical flask, 250 ml of conical flask which is used to collect the water sample for the test, and burette, that is 50 ml burette which is used to collect the sulfuric acid for the test. We do require reagents for the test. So 0.1 normal H2SO4, this is 0.1 normal sulfuric acid, that is H2SO4, which is taken in the burette for the alkalinity test. Phenolphthalein indicator, which is used in the alkalinity test mainly to neutralize the hydroxyl ions. Methyl orange indicator. When we add this to the sample, the color changes to orange, and we require water sample, which is used, or this water sample is used for determination of alkalinity. Before conducting the test, we need to rinse all the glasswares. This is the wash bottle that is with the distilled water. So we are going to begin rinsing with the pipette. Next, the conical flask. We'll also rinse the funnel. Then the burette. After rinsing all the apparatus, we need to rinse the burette with sulfuric acid, because we are going to take the sulfuric acid in the burette. So once rinsing is completed, we have to fill the burette with the sulfuric acid. So we need to adjust the sulfuric acid to this mark, that is to 0. So now the burette is filled with sulfuric acid. So after filling the burette with the sulfuric acid, now we have to take the water sample in the conical flask, that is around 10 ml of the sample. So before taking the sample of 10 ml, we are going to rinse with the water sample. So now it is rinsed with the water sample. Now we have to pipette out around 10 ml of water sample to the conical flask. Before that, I'll just rinse the pipette also with the water sample. So now I am going to take 10 ml of water sample. So the sample has been taken up till this mark. Now the sample is to be transferred to the conical flask. So even the last drop has to be transferred. So now the sample is taken in the conical flask, that is around 10 ml of sample. Now we are going to titrate the sample with the sulfuric acid. So for that, first we have to add the phenolphthalein indicator. Around 2 to 3 drops of phenolphthalein indicator. The color, as you can see, turns to pink. Now we have to titrate this sample with the sulfuric acid that is taken in the burette. So now the color is changing from pink to colorless. So as you can see, the color has changed from pink to colorless. So once this point is reached, we have to note down the reading from the burette. So once the color has changed from pink to colorless, now we need to add the methyl orange indicator. The color changes to orange. and then continue the titration with sulfuric acid. So as you can see, the color has changed from orange to red. Now note down the reading from the burette. This completes the alkalinity test, that is the titration part.
At MSR UAS, we spark your imagination unlike any other.